Hey everybody, this is Todd Frazee, and this is the next in the series for the mill program, the S60-115 cam for the main post. We should have already done the drive post, which is has some similar features, similar material, and hopefully you can recycle some of the work you've done. This is quite a bit more complicated part though. We've got a slot in the end. We have a high tolerance pin that presses in. We also have press fit reamed holes here that are different depths. We have a slot. We got a chamfer, and we have the same hole pattern that we have in the 139. We also have the same 30-second radius running around the outside, so we should be able to recycle some of the code from there. I don't see any way around it, but this is a 1, 2, 3, 4-sided part. We have to approach it from 4 different angles, and actually 5 if we're actually going to put the chamfer on the back side of the part. So let's get started before any further ado. And again, we're not going to focus on work holding. It is very important, but this class is more focused on the programming side. So let's look at comparing in Solid Works our two parts that we're working on. So on the right hand side window I have the 139, which we should have programmed in the last class or last tutorial, and then over on the left we have our 115. Now if we approach this from a similar standpoint, where we start out in an orientation something like what we see here, on the 139 we milled off the end, we did the radius, and we did the hole over here. It's a different size, but we could do that. And then we have work to do on the side here, and this is a flat plane that's parallel to the plane on the opposite side, so that could be a clamping surface. And then we have this slot that needs to be cut from the end with a saw. So the overall length of this part, if I were to measure it, about 4 inches. So in a 6-inch vise we wouldn't be able to have both sides sticking out. So we'd have to assume that we're going to make a special fixture to make this. Perhaps the first operation is done on the vise, and then the following ones are done in some sort of dedicated fixture, and then perhaps we stand it up on end in a vise. But okay, so here we go. We're going to try to copy the operations, but I want you to keep in mind that our operation numbers may change. I just want to be able to recycle the code that we've used. So I know op3 was all the drilling in the end, so we definitely want to right click on that one and select copy and go over to the 115, right click, and we're going to paste that one in there. Okay, so it looks like it automatically added op4 to the number. I'm not sure if that's actually the op order it's going to be. And then we have this routine here. We're going to copy that one as well, and we're going to paste it. And then we're going to go over to the first op and do the same thing. Copy and then paste. Okay. Alright, so we're all out of order. We got different orders. Let's collapse this down. And I'm going to put them in the order in which they were done in the other part number. So if I were to drag them around, I've got them in the order in which they were done in the 139. Okay, So I'm going to go ahead and save in both files just to make sure I retain everything. Now I'm going to close the 139. Okay, let's expand it out. And I'm going to zoom to be in an orientation like you'd be in a vise where you're standing where the operator is. So again, we're going to be milling just enough down to get the radius. We're going to drill this hole. We're going to mill off the end. We need to make our stock. Okay, so let's go to what's called Op2 here, and we're going to rename it. First, the correct part number, Op1. Okay, let's go into the setup. We're going to go edit. Yes. We're going to reassociate the geometry. So we've got our part, and I'm going to assume we can hold it in the vise for this first operation. Okay, so we've got the model highlighted. We're going to call this the 115 Op1 instead of 139. We're doing milling. And on our stock, we need to set our origin before we mess with the stock. So our origin is going to be selecting Z, and we can select an X-axis on this one. So Z and X-axis. Our Z is going to be in the plane of the top of the material, is along one of these parallel lines. Okay, and that's pointing the wrong direction, so we're going to reverse the X-axis. We're going to go to stock box point, and bottom corner 3 is fine. That's where it was on our last job. Now we're going to look at our stock. So we should have 30 thousandths left on the either end, and we're making this out of bar stock that's already the same size as the footprint of this thing. We don't need to make the stock any bigger on the y-axis or the vertical axis, because we're starting with ½ inch by I believe it's 2-inch mild steel bar. So we've added 30 seconds to either end for our sockets. Okay, we're going to scroll down. We're going to change our name from 139 to 115. And you might have caught this mistake in the last tutorial, but this should have been S60-115 Op1 instead of what I pasted in there. I had something else from Canvas accidentally in my clipboard. Okay. Alright, so we've got the stock now set up, and now we're going to start our machining. So the first operation was a spot drill, and it spotted out a much larger hole than what we have here. So we're going to come in and we're going to measure, we're going to evaluate what this chamfer edge is. So if you go to evaluate, measure, pick on the outside diameter, we have a 83 thousandths hole. Alright, so we're going to go back to this routine, go edit, yes, and we're going to keep the tool, we're going to keep all the feeds and speeds at what we did in the last one. We're going to select our hole, which is just going to be the chamfer surface, and then we're going to go to depths, and we're going to leave all this the same, except for we're going to change this to negative 0.085, which is the diameter of that countersink, and we're going to divide that by 2. Okay, so we have a much shallower drill point. Okay, and we can keep the rest of this at default and accept. So we've got the first routine done. Now, if we're going to follow up on that, we're going to go ahead and drill through the part. We have two choices. One, we can drill all the way through, or we can drill halfway through and drill the other halfway through from the other side. It's kind of semantics. With the small diameter of the drill bit, it could be it could have some drill wander, but what you do to combat that is you do lots of small pecks. Okay, so we might have it wander a little bit and be off center. Take the next operation, and I guess we can go ahead and We could either edit it or we could delete it and make a new one. Let's just go ahead and edit for posterity. I'm going to pick that up and we're going to change our drill bit from a 1/4 inch drill bit to the drill bit that we would use preceding the press fit reamer. So our press fit reamer it's the number 53 reamer. That was the reamer we were going to use. So the drill we use for that is the stub drill, number 54 stub drill we're going to select. It's reset its RPM. I think that 5,000 is too fast for steel, so we're going to go 2,500 with this small diameter one. We're only going to go 8 inches a minute on this, and our plunge rate is going to be 8 inches a minute, and our retract 8 inches a minute. Our next tab, we're selecting what is the hole we're going to drill. So we're going to start with the chamfer. We're going to do the cylinder, the cylinder of the opposite side, and then we need to rotate around and get the chamfer here on the opposite side. And we want to auto merge that so it treats it as one drilling cycle, not as separate drilled holes. Okay. We're going to go to the heights tab. We're going to keep all the stuff at the beginning at default. We're going to go from top of hole to bottom of hole, but we're going to break through and we're going to go 10,000 steeper. So that's fine. It's calculating a different breakthrough value because it's a smaller diameter drill. The last tab, we're not doing a drilling and just wrap it right out. We're going to do a deep drilling cycle. And I want to go 55 thousandths drill. And if I were to go half of that, it'd be 25 thousandths. So 0.025. We're just going to leave that where it's at. And so it's going to peck until it gets all the way through. Okay, so we've got our 16th drill going through real slow, lots of pecks. Probably take an hour to get through, but we should have a fairly straight hole when we do that. Alright, so now the next is the pocket, and that was to do the pocket for the bearing. We don't need that on this routine, so we're going to delete that. The finished contour, we don't need it for this operation, but we could possibly use it for this here. So I'm going to drag that operation down to op 3 and we'll deal with that later. Okay, so now we have our 2D contour, and that was with a 1/4 inch end mill. Okay, and I believe that trimmed off the end of the part over here as if it's sticking out the end of the vise. Okay, so we're going to keep all that at default. We're going to go to the next tab and we're going to select a different set of edges. So it's here, and it gives us a crossed. We're going to go to heights, and we should be able to leave everything as it is. It's going to go to model bottom and then machine pass by 10 thousandths. Go to the next tab, and it's all of our rough and finishing passes. If it worked on the last part, we'll use it on this one. Go to our last tab, and it looks like we can leave everything at default there. Hopefully it'll come out the same way. Okay, so we got our horizontal rough cuts, we've got our straight lead-ins. The next routine was to clear out material so that we've cut down beyond the radius so that our corner rounding end mill can come around and have clearance. So we're going to right click on that routine, which is also the 1/4 inch end mill. Contour. We're going to keep the first tab alone. We're going to go to the geometry tab. We're going to select the first edge, and it should wrap all the way around. We're going to go to the heights tab. We'll leave all this at default. We're going to go 5 thousandths deeper, just like we did last time. And the roughing passes on the sides, I'm going to do a few roughing passes on the outside. It's really just going to cut air over here, but over here it should clear out quite a bit of material so that the corner rounding end mill doesn't touch anything on the scrap side of the part. Then we move over to the last tab, and we should be able to leave all this at default as well. So we select that, and we should get a routine that has 1, 2, 3 rough passes and then a finish pass, with it leading in from the edge. Okay, And then our last routine is going to be the corner rounding end mill. And we're going to leave pretty much the first tab at default. Second tab, we're going to select a different path. Heights, we can leave those all at default. We can leave the 2D contour at default. And we can leave the last tab at default. There we go. So we got our corner rounding end mill that should be taking a single roughing pass and then a finishing pass. Okay, so we've now recycled all the tool path from the 139 part. We now do need to add one additional new tool path, and that is the reamer for the 16th press fit hole. Okay, so we're going to go to our, we're going to make a new drilling cycle. Okay, and we're going to select for that tool from our library. We're going to select the reamer that's undersized for a 16th pin. So I believe it's the number 53 reamer here, tool number 9. We're going to select that tool. We're going to stick with the speeds we have here, except we're going to slow down the feeds. I'm going to go 10 inches a minute with, actually we're going to go pretty slow with this. This is a pretty small reamer. Let's go 8 inches a minute. And on all of these. Okay, and we're going to select our hole features, which are going to be same as the corresponding drill features that we had selected before. Okay, and it's going to auto merge those into the same drilling routine feature. Okay, and then we're going to go to heights. We're going to leave all this other stuff to default. We're going to go from hole top, and we're going to go to the hole bottom, but we want to go a little bit deeper, make sure our chamfer clears. So we'll go negative 0.01. And that should be fine because our drill bit went a little bit farther. Okay, then we're going to go to our next tab, and we're doing reaming, feed in and out. We're going to leave that at default, and we'll accept that tool path. Now it's not sequence-wise, it's not really where we want it. We want it to go from the deep drilling right to the reaming, so let's move that up in the tree so that it occurs right after the drilling that preceded it. Okay. Alright, that's it. Now we're ready to move on to the next routine. Now we're going to go to Op 3. So right click on it and make it the default folder and expand it. Okay, our 2D finish contour that I selected there was for the bearing. I thought we might use it in the future. We're going to kick it down to the next op just to get it out of the way. So now we have flipped the part 180 degrees and we're looking at the opposite side. So I'm assuming we're going to use a fixture. We're probably going to use the same scheme where we use this hole for location. And then we've got a clamp over on this end. So like in the last one, we had to create a point in order to select our origin. We're going to use that as a reference. So we're going to go to sketch, and we're going to sketch on the face here, and we're going to create a point that's at the center of the hole that we're going to use as our pin reference. So that was drilled from the opposite side, so the location of the top of the hole should be very accurate. Okay, so we've got a reference we can use. Now we're going to exit that sketch. Okay, it's given some warnings, but it's because we've copied toolpath and it's warning us that some of our toolpath is ineffective, and that's fine. We're going to regenerate all of it anyway. Okay, so now we're going to set up our stock for the second side. So we right click on the operation and we're going to go edit. Yes, we know we're reapplying geometry. Okay, so we're going to change the name to the 115. That's op 2. Okay, we're going to scroll down and we're going to reset with a Z and X axis. So we'll pick the face as the X axis. or I'm sorry, the z-axis, and we're going to select as the x-axis one of these horizontal lines, and we want to flip the orientation so that the x-axis is positive to the right. And now we're going to go to our selected point that we created in our sketch as the origin point, and that way our tooling is based on the origin being at the center of that pin. Okay. Alright, now we slide back up in our menus, and again we have no extra stock on the right, but on the left we still have extra stock. We have stock all around the part, so that worked out well. Now we're going to zoom down and we're going to change our number from 139 to 115 to, and this is the 115 operation up to. Okay, so we have the stock all laid out.